All right, well, that's okay. The first part wasn't all that memorable anyway. So let's go ahead and take a look at Chapter 11. That will be recorded. So. Okay, so this last chapter is on configuring and testing your network. You got a kind of an early start last week when you connected using a console cable, a serial cable, to the router and using hyperterminal so that you could talk to the router. It was really kind of a superficial lab, but critical because you'll be doing that every time from now on as you connect to equipment to be able to configure it. Because the Cisco internetworking equipment that connects networks together, both on a local area network, on an internetwork, and even with wireless networks, are all configured the same way. And they don't come with their own keyboard and monitor. You've got to, supply that, and you have to use software, a terminal emulation software, to be able to connect to it to do it. So this chapter explains the role of the iOS, the Internetwork Operating System. That's Cisco's proprietary name, but we hear iOS coming up quite a bit. It's an OS, it's an operating system. It's for the devices, the equipment. We're used to Windows as our operating system. That's what we typically use on most computers, but there are other operating systems out there, Linux and other desktop operating systems, and then Apple, of course, too. And then there's operating systems for other equipment, too. And Cisco has their own proprietary operating system. And it is a command line interface. So they do have a GUI that they provide, but you're not going to be tested on the GUI. Most network engineers don't use the GUI. The command line is faster for them to do the things that they need to do, plus takes no resources, right? A GUI interface requires resources. You have to have more RAM, more processing, so you can show and display the GUI. Command line doesn't take anything, so they can get away with little processing available just for interfacing. So you're going to use the command line interface to perform basic router and switch configuration and verification. You're going to be doing subnetting again. I told you it's going to come back in every chapter, so there's some network addressing scheme that you're going to have to come up with. They keep it fairly simple at this point. You'll see it again in another chapter in the next course. There's a whole chapter dedicated to subnetting again in the next course, the routing course as well. And then you're going to use some utilities to verify if you've already used some of those, ping, trace route, those kind of commands that you use to test your network. All right, so the role of the Internetwork Operating System, the iOS, and Cisco's proprietary iOS is on all of their equipment. So it's responsible for, accessing the interfaces, the ports where you plug in the different networks. It does routing, it does addressing, it manages the resources on the device. So a Cisco router is another computer. It has a processor, it has RAM, it has interfaces, and the operating system manages all that. But it also does security, so there's built-in security into the operating system that you need to learn how to configure. In fact, there's a whole course after CCNA dedicated to security, network security, called CCNA Security. We teach that here. It's actually taught by Wallace, who'll be your teacher coming up for the routing class, and it's available in the springtime. And you guys could be ready to do that one at the same time you do the switch and WAN class, actually. And then it does quality of service. Remember we talked about not all traffic is the same. Voice over IP traffic, a telephone call needs a higher priority to make sure the whole message gets through, although it doesn't need guaranteed delivery of everything, but it needs to be allowed to go through the gateway first, maybe, and have priority. So the quality of service features are there as well. Oops. Okay. So all Cisco devices use the same iOS, even though they're different. So Cisco routers, Cisco switches, Cisco's wireless access points. They all use the same operating system. So that's kind of good for you as a network administrator, because then you're familiar. If you learn the iOS, you can then take those same techniques on any of the different devices. There is a startup configuration. You didn't see that when you logged on the little lab that we did in Chapter 10, because those routers that you connected to didn't have a startup configuration. In fact, they came up with a message. Do you want to, go through a prompted dialogue to set up the configuration? So we're not going to want to do that. We're going to actually configure the configuration. So there's a startup config that's stored in NVRAM, which stands for non-volatile RAM. That's RAM that is permanent, charged. So when you shut the router off and turn the power off, the startup config stays there. It's there because there's a battery on the motherboard that keeps it available. So when you lose power, the battery kicks in, right? Just like your CMOS settings on your PCs, right? Same thing, or benefit from the batteries that are there. So that startup configuration is copied from NVRAM to RAM. So when you boot up and start up the router, it loads the configuration into RAM. And that becomes the running configuration. So it's only the running configuration that is ever doing anything. The startup configuration is secondary storage. But it's stored there in the event that you lose power and have to reboot the system. So when you make your configurations, you're doing it directly to the running configuration. And it happens in real time. As soon as you make a change, it immediately changes the configuration on the router. And it's the running configuration that directs the device operation. The iOS and the config file are directly related. You use iOS commands to create the running configuration so that it can operate the interfaces, do routing, do addressing, do all those things we talked about earlier. Now there are different modes. So when you first connect to Cisco's device in their iOS, the initial mode is called user mode. So when you first connect to it, that you were in user mode when you connected to the router the first time last week in Chapter 10. So that's this mode up here. That's user mode. User mode has a very limited set of commands that you can do. If you know Linux or Unix, it's sort of like your user account. When you connect to a Linux box, you connect with a user account. And then if you want to do administration, you have to switch the user, right? The SU command and get the root command. Remember, you can't access a Linux box remotely with root. You have to access it with a user account and then switch to root. And root is usually protected, right, by a password. Same thing happens here. So you move from user exec command mode to the router to the privilege exec, and you'll see that the prompt will change, just like your prompt changes in Linux when you log in as a switch users. So it goes here from just a greater than sign to the pound symbol, and there in privileged exec mode, you can configure the router. You can do all the commands. You have sort of super user rights there. So you can debug, you can reload, you can configure, everything. When you configure, you go to global configuration mode, and there the prompt changes again. Router config pound. Here's where you do the configuration. Set the host name, put in the IP addresses, do IP routing, set up security, connect to the interfaces, all those things. And then there's actually a fourth mode as well. Kind of hard to see on here, but this fourth mode is actually specific configuration. If you're configuring the interfaces, you go to a lower level on the hierarchy that's more related to the commands that you're going to be configuring there. In this case for the interface, in this case for routing. So we're going to get a chance to take a look at all those. So those are the primary modes of the iOS. And these are true for the switches and for the routers. So Cisco switches, Cisco's routers have the same iOS. And the commands that you use are the same. So when you go into user mode, they look very similar. This one's the switch that you're connected to, because it says switch, and this is the router. Those are the host names by default. They can change. So don't rely on this to tell you whether or not you're on a switch or a router. You should know that you're connecting to a switch or to a router. Right? But anyway. Privilege exec mode. This is where you're going to be able to control, and this is sort of the administrative mode where you can examine the router, debug, test, file. Here's global configuration mode, and here are other configuration modes where you do complex interface, line, routing commands. So they'll move up and down. So you're going to be moving up and down in this hierarchy of command space. A little different than a computer operating system. Okay, there's a syntax, a command structure. Got to type it in the same way. It's still a dumb computer. It was programmed to listen, understand commands in a certain way. The delimiter between commands, like in Unix, is a space. So you put the command, like ping, a space to delimit it, and then the argument, right, what you're going to be pinging, an address in this case. So all commands are kind of like that. They have a command and then arguments after it, and the parts of the command are separated by the space. So in the Cisco's iOS, the space is the delimiter, which is good because we're used to putting spaces between things to get meaning, right? That's how our language is built. Now, the nice thing about the Cisco iOS is it's very helpful. It has context-sensitive help built in. So if you don't really know the command, you can type in the first couple letters, put a question mark after it, and it'll finish. Like the CL could be clear, or clock. Clock with a question mark could either set or set the time and date, those kinds of things. So you have context-sensitive help. Like Unix, it also, and new Windows command line, it'll finish commands for you too. So you can begin typing. As soon as you have a uniqueness about the command, you can hit the tab. It'll finish the command for you. That's another shortcut. That it makes a difference for network administrators who prefer the command line, because this is just faster to get things done. Because you have things like context-sensitive help. You've got uniqueness commands and history and things like that that you can use. All right, so just about the parts of the router where software ends up being stored. Remember, the router is a computer, and it has a motherboard, it has chips and things in it. It doesn't have a mechanical hard drive, but it has a flash memory hard drive instead. So in RAM, you can type a command like show the version, and it's going to show you the version of the Internetwork operating system. It's in RAM because it gets loaded too. You can show processes on the CPU. It's the active configuration file. It's where the routing table is stored too, and the buffers. So everything's in RAM. So when the device is running, the important information software is running in random access mode. NVRAM is non-volatile RAM. It's a small amount of RAM. It's a chip on the board. It's got your startup config. The backup configuration file is there. So you can see that by typing in show startup config. It'll show you on the screen what's the startup config. Your startup config and your running config should be the same, right? That's going to be your goal. You're going to create the running config, and then you're going to save it as startup config afterwards. And then flash is like the hard drive. That's where the operating system exists. And the operating system file is pretty big usually, 6 megs, maybe more. It depends on what features are in there. That's the iOS is stored there. And then interfaces are the other part. That's the Ethernet and serial interfaces. And you can do a show interface to see what interfaces are on that router that are available. All right, so configuration modes again. When you first connect to a router, it's going to show you router, right? That's the host name by default, and then the greater than prompt, and then a little blinking cursor waiting for you to type something in. You'll go to privilege exec mode, and then from there you can go to global config, and from global config you've got a lot of different specific configuration modes depending upon what you're configuring. You're only going to be doing these 3 configuration levels to start with. Interfaces, like the fast Ethernet interface, the serial interface. Lines, like the console line or the telnet line or the auxiliary line, those kind of things. And routers, the actual routing protocols, which you'll learn how to configure as well. So on the back of the router, accessing the device, you're going to be looking at this very setup here, except we don't have this little switch module on ours. We have separate switches. But the 1841 routers, that's what this is, has a console port. That's this blue, baby blue, and it's labeled console. That's where you plug in the console cable. But remember, in our lab, we have those hardwired to the patch panel. So we go to the patch panel instead. It's got 2 fast Ethernet ports, fast Ethernet 00 and fast Ethernet 01. There's 01 up here, 00 is down here. We also have that 00 port configured into the patch panel, so you plug things in there. And then there are serial ports here as well. And when we see them on the rack, you'll see these serial cables, these thick blue cables hanging off there, connecting the serial ports together. Remember, serial ports are not Ethernet. They're a different kind of technology. PPP, HDLC, frame relay, whatever the service provider provides. And we'll simulate all those different types of technologies in future labs that you'll be doing as well. All right, so some basic command line commands. You're going to learn how to do all these because you have 2 labs where you have to do these. And then you have the skills assessment where you have to do it again. All right, so you're going to get plenty of practice. And then these basic CLI commands will have to be done for every subsequent lab that you do in this sequence of courses. So with the routing class, every time you do a lab, you're going to have to first configure the host name of the router and these other things as well. So basic commands. Naming the device. So by default, the name was router and switch, right? So these are 3 routers here. Here's a switch. You want to have names assigned to them, and the names usually have some logic to them, right? And they're meaningful. Not the devices don't care. The operating system doesn't care what the host name is, but we care. So we want to be able to identify things by the host name. So you want to give it a name. How do you do that? Well, from the router user exec mode, you type enable. So that's like the SU command in Linux to move you to the administrative level. You type enable. That changes the prompt to privilege mode. See, it says router #. Then you go to configuration mode, and you type in configure terminal. And there are shortcuts for this that you'll learn pretty quickly. But configure terminal. Hit enter. That moves you to global config. Remember that prompt? Router, config, #, and there you type in the command for the host name, which is host name, and a space, the delimiter, and the new host name. We want to call this router Atlanta Headquarters, HQ. That's what it's called. So now it has a name that can be assigned to IP addresses that you can ping. That could be part of the domain name. atlantahq.cisco.com or .aloni.edu or whatever it might be. Okay, then you're going to set up some security, because when you first connect to the router, it's wide open. You connect right into it. You can get right to the enable mode. You have a console port that's not protected, so you're going to want to add some basic security, first level security. You're going to want to set up a console password. You don't want just anybody plugging a cable into the routers and connecting to them. You want that password protected. So you do that. This happens to be a switch. Doesn't matter whether it's a switch or a router. You're in configuration mode. Remember how we got there? Connect, enable, switch, right? Config, line, config terminal. You do line console 0, password Cisco, and login. All right. And then when you press return to get started, it's going to ask you for the password. So when you plug in the console cable, so you've protected the console port. Simple. Now you don't have to write these down because they're actually listed in the lab you're going to be doing. It'll tell you what the type for each of these. Eventually you're going to have to memorize them or learn them, not memorize them, just learn them. The nice thing about this is you can do this every time, so it's going to become like second nature to go in and do all these things. Telnet. Telnet is an application layer protocol at the very top, layer 7. It needs IP to work with, and then it's nice because it's remote administration. Right now, you got to get to the router itself, plug your cable in to configure it. But later on, when you're in charge of that router and all those devices, you want to be able to do it remotely. You want to be able to log into that equipment from your cubicle or from home, and you need to use an application like Telnet. Well, Telnet's not real secure, but you'll see there's others that you can use too. So to configure Telnet, you need to do the same thing. Enable mode, configure terminal, config line VTY, which is the virtual terminal, 0 to 4, which means you can have up to 5 connections through Telnet simultaneously. So that means password, you're going to call it Cisco. These passwords are terrible. It's not the kind of passwords you want to really use, but you'd be surprised how many internetworking devices, Cisco routers out there that are in the field, that are in production, that have Cisco as their password because nobody changed it. Anyway. But for our purposes, we're going to use Cisco because it really helps us out in the lab. If you put a password on there that we don't know, it's pretty hard to guess. We have to just kind of wipe the whole thing out. It takes about a half an hour, and gets people angry. We have to do that. So use our regular passwords. Don't use San Fran as a password. Enable password, San Fran, that's to password protect the enable mode, the administrative mode. So when you log in as a user, you type enable, it moves you right into administrative privilege mode. What you want to do is password protect that. So that's enable password. Yeah, this is not going to work with the space. Doesn't like spaces in the password. This is an encrypted password, enable secret. You can use that instead. We'll show you the difference between those when you get out in the lab as well. I never quite understood this command. This is a login banner. So what it does is when you first connect to the piece of equipment, it gives you an announcement about that. And usually it needs to be something that is authoritative and causes you to pause, right? So this one, when you first connect, it says this is a secure system, authorized access only, or something like that. I got into the habit of being kind of nice and saying, oh, welcome to the Aloni network, having a nice greeting on the banner like that. It was fun, and we were doing that for many years in class, and then on the CCNA exam, people were dinged on that. They couldn't have it had to be a serious banner announcement, right? So anyway, we need to do that as well. The banner command is the most complicated one because it's not very intuitive. You type in, again, config terminal, banner, space, MOTD, which stands for message of the day, and then you got to put delimiting characters. You can pick whatever you want. I would use the pound symbol to start the beginning of the string of characters that are going to be the announcement, and then an ending pound symbol. This one is the hardest one for people to do. You're going to get stuck on the banner command, I just know, because you're going to leave something out like the delimiter, and then if you leave this delimiter out, then it's going to take the T in this as the delimiter. You forget to put the delimiter. Then the T, capital T, will become the delimiter, and you don't have a capital T at the end, so it'll never quit. You'll be lost in banner mania, forever. So anyway, that's the banner. You can check your work by typing in show running configuration. You'll learn that there's a nice shortcut for this. Just show run. Show space run does the same thing. Or you can type show run tab, and it'll finish the whole command for you, running configuration for you as well. Then it echoes back to the screen what your configuration is, host name, Atlanta HQ or whatever you called it, the interfaces. Notice these interfaces are not configured, right? No IP address. They're all shut down. That's all by default. So we haven't got there yet on the interfaces. So show running config lists the complete configuration currently active in RAM. The active configuration can be copied to NVRAM by typing copy running configuration to startup configuration. So that's the way you save your config. I like the shortcut copy, run, space, start. That is an easier way for me to do that command. So backing up, your configuration file can be done this way as well. Copy running config to TFTP. Does anybody know what that is? TFTP? It's another layer 7 protocol. We know FTP, right? FTP is File Transfer Protocol. T stands for trivial. It's Trivial File Transfer Protocol. It doesn't require TCP. Remember, FTP requires TCP. Three-way handshake, make sure the whole file's transferred. Trivial FTP doesn't. It uses UDP. It's very lightweight, simple little TFTP server to store configuration files, things like that. Low bandwidth requirement, low resources. You don't need a lot to run a TFTP server. Anyway, that's mentioned in here. This actually stores the configuration on another box outside the router. Remember, your routers, that's your gateway. That's an important device, right, on the network. You need to make sure that your configuration is secured, running, and backed up, right? So if something happens to that device, you can reload the configuration file from a TFTP server. You can also create a text file to restore your configuration from Hyperterminal. You can copy, capture the text once you've done it, and save that in a notepad, because your configuration files are ASCII text files. You can store them in a note file, keep them handy as well. Now you're going to learn how to configure the routing interfaces as well. This is all these commands, by the way, work in Packet Tracer. So everything can be practiced there in Packet Tracer as well. In fact, those of you that are in the online class, you'll be using Packet Tracer to do these activities. So all interfaces are accessed by issuing the interface command at global configuration prompt. In the following commands, the type argument includes serial, Ethernet, fast Ethernet, gigabit Ethernet, different types of interfaces to show up. There's a couple things you need to do. The interface and the type, fast Ethernet 0/0, that interface, or serial 0/0/0, those kinds of interfaces. And then the following command is used to administratively turn off the interface. So you can shut down the interface with the shutdown command. But we notice by default, all the interfaces were already shut down. So we have to turn them on. And a very common approach with Cisco iOS is to take a command like shutdown, which turns things off, and say you want to do the opposite of that. So we do no shutdown. No shutdown turns the interface on. That's the way it is. There's a lot of the use of no to reverse things that you've done. So if you put an IP address that's the wrong IP address on an interface, and you want to take it out, you have to say no IP address, this one that I just typed in that's wrong. You have to take it out like that. Okay. All right, so the interfaces. We're going to configure Ethernet interface, fast Ethernet 0/0, that's this one right here. We go to enable mode, config terminal, config interface, fast Ethernet 0/0. That's this one. You're going to learn that you can abbreviate this too. You can say F for fast Ethernet 0/0. That's another shortcut. Works the same way. It moves you into the config interface level. In this case, the interface that we're going to be configuring is fast Ethernet 0/0. We give it an IP address. That's how you assign the address. So different than Windows, where you type in the GUI the IP address, the subnet mask. Here you have to type it in all on the line. IP address space, the IP address space, the subnet mask for this device. So 10.1, 255.255.255.0, what kind of address is that? Class C. This is what's unique about this one address here? First usable one. And they are assigning it to the gateway. So in this case, the first usable one goes to the gateway. F00 is the gateway for a particular local area network. Now, you can also do descriptions. So in your configuration file, you can add comments to the configuration, like a description of the interface. This is the Fast Ethernet 00 is the interface that is for Building B sales local area network. So you can type in an information about the interface. You're going to have to do that as well. Here's serial 000, which is a WAN connection. This is to Perth organization here. That's the description. So someplace in Australia that you're connecting to, right? That's how you get that. All right, how do you test your TCP/IP configurations? You do it from your PCs. Remember, you can ping your own interface to make sure you have a local connection. And then you can do the same thing from within the Cisco IOS. There's a few commands you can do here. Here's ping 192.168.254.1. Make sure you can connect to your gateway, make sure it's operational. You can do this command, show space IP space interface brief. It tells you which interfaces are configured. Right? We've got here Fast Ethernet 00 and serial 00 are both given IP addresses. Both of those interfaces are up, right, and working. The other interfaces, the other two, are not being used, so they're down. So this router can actually connect to 4 different networks, right, to each of those interfaces. Remember, routers are the internetworking device. They are the ones that go between networks. So all the routers we have out there could support up to 4 networks. They could be the gateway for 4 different networks. Testing the gateway, of course, you ping the gateway, right, and get a reply. That's the gateway 10.0.0.254. That's what you type for ping. You want to make sure you can do that. You're going to need to configure for the lab a little network just like that. You should be able to successfully ping other hosts on your network. In our lab, there's only 2 of you together, right? 2 PCs together. You can ping each other. Make sure you can do that as well. And you can use traceroute to trace the route. That's a very useful one, even though most of our labs will only have, 3 routers. I think I showed you traceroute with Google. Remember, that was 11 hops away. Those are routers. Each one of those hops is another router along the way. You can use that here as well. And you can use traceroute from the router interface as well. So ping, traceroute, all those troubleshooting commands that you use in Windows from command line, you can also do it in Cisco iOS. Now, Cisco's iOS, the traceroute command is traceroute, all written out. Remember, in Windows, it's traceRT. That's different. Different operating system, that's the way they do it. But same effect. And then troubleshooting, ping helps. Make sure you get the right configuration. Make sure you have the right addresses. So you're trying to ping the gateway, but the gateway actually has a different address. Right? You've got to pay attention to that. Remember, IP addresses are logical. They're for network administrators and for routers, not for anybody else. So they need to be, they're logical, but they need to be correctly configured too and typed in properly as well. So that's chapter 11. Let me show you the lab. This set of slides?
Yeah.
Yeah. Should be there, chapter 11. I'll put it up there if it's not. Make sure. Okay, let me take a look at this lab here. Okay, so here's the way this lab is set up. This is 11.5.1. This is the first of 2 that you have to do. And the skills assessment is almost exactly like this. Same scenario, same topology. 1 router, 1 switch, 2 hosts, right, connected. This host is directly connected to the Fast Ethernet 00 of the router. What kind of cable does that have to be? crossover because it's computer to computer. A router is another computer. It's another host. It has to have an IP address. It has to have a subnet mask for that interface. And because you're connecting directly, you need to use crossover. Now here, for this connection, we could go directly, but we didn't. We introduced a switch, which is a more common connection. Most hosts on a network connect to a switch port, because switches are the hero of local area networks. So in this case, we're going to use patch cables. You've got to do all this too, by the way, and plug all these things in out there. And you're going to need to build it in Packet Tracer as well. So you're going to configure the Cisco router global configuration settings, password access, the router interfaces, and then you're going to save the router configuration file. So there's a couple of steps that we went through in the slides. It tells you what you need here, what you're going to be doing, and then it gives you a scenario, which is the hardest part, which is the subnetting. You've got to get that down first. So it's paper and pencil stuff. So I'm going to kind of do this one together because we want to get out there and spend as much time doing the configuration as possible. So here it says, given an IP address of 198.133.219.0/24. So this is actually a Class C public address. This is not the typical 192.168. Right? This is a real IP address. With 4 bits borrowed for subnets, fill in the following information in the table below. So all they're doing with this lab is they're going to just divide up this Class C network with 256 addresses into smaller little subnets. But they're borrowing 4 bits. So they're borrowing 4 bits of the host portion. How many subnets does that give you? 16. And how many hosts are there on each of those subnets? 14. So 16 minus 2, right? So that's what you have. So every 16 is another network, right? So 0 is a network, 16 is a network, 32 is a network, 48 is a network, 64 is a network, and so on. So they're going to want you to type in. The very first network is 192. I'm so stuck on that 192. It's actually 198, right? Dot 133.219.0 is the first network. What's the first usable host address? 198. I'm going to cheat here because every single one of them is going to have that same startup, right? Dot what? 1. What's the last usable? Whoops. 14. What's the broadcast? 15. I don't know my new computer here. 15. So what's the next network? What is it? 16. And first host? 17. Last host? 30, right? Then 31 is the broadcast, then 32. Okay. Now, they're going to want you to fill this whole thing out, and this usually takes a long time to write all that down. So this is the pattern, right? So we know this one's going to be dot 32, right? And this is going to be dot 33, and the last one's going to be dot 46, right? And this is going to be dot 47, because all the first 3 numbers are all going to be the same for every single one of those. Okay, so I've done subnet 0, subnet 1, subnet 2. Remember, we're going to have 16 altogether. There's 16 little subnets. We've taken that big chunk of networks and we've divided it up 4 times into smaller pieces. So we have 16 little pieces, each one with 16 addresses minus 2. Okay, so what's the maximum number of usable subnets? Okay, this is, well, nowadays you get all 16, right? And the usable hosts per networks, Kareem already said it's 14, right? 14 usable hosts. You're going to be plugging a console cable in from one of the hosts to configure the router. Now, you're going to work together. There's only one router, so if you work with a partner, one of you has to be driving, and configuring. And the other one is directing, like the way it is in my car. When I'm driving, my wife is directing. Okay. And then physically connect all the devices, and then here it takes you through all the steps. Router enable mode, right? Takes you through that. And there's questions throughout the little lab as well. And I've got hard copies for this for each of you to do as well. Host name, router 1 they're going to call it. So everything is done. Here's configuring the banner, right? MOTD banner. Configuring the iOS passwords, right? Privilege access, that's the enable password. The console password and the telnet password. Commands are all here for you to do. Now the interfaces. Let's see, what do they want you to do here for the network? To tell you what, let me see, I'm sorry, let me go back up to the beginning and say what the networks have to be used. It doesn't tell me here. Well, somewhere in the lab it tells you which network to use. I can't remember where that's at exactly. Back here, interfaces. Well, the first IP address is used to configure the host. So they want you to use the first available of whatever subnet you pick. Subnet 0, the first subnet. That's the easiest way. And subnet 1 will be the other network. Because remember, we have two networks, right? We've got this local area network, and we've got this one too. We have two networks that each have to have their own subnet address. So we can make this one subnet 0, and this one can be subnet 16, right? 0 is our first network, right here. This could be our second network. All right. All right. You're going to configure the IP addresses, configure the host computer, verify your network connectivity, save the router configuration files, save the RAM, save the configuration into NVRAM. Here are the commands that you'll be using as well. They're all listed here for you. And then you're done for this lab, for the first one. So we've got a good 2 hours to get that first lab done. The second lab is a little more complicated on the subnetting end. So you're going to have to do a little more subnetting. So I'm going to give you a copy of that tonight too, and you can prepare that ahead of time. So you have your subnetting kind of scheme paper and penciled all out. So when you come back on Thursday, we can do that lab as well. All right, so any questions from those of you that are online? You're going to see the skills assessment is very similar to this. You're going to have to build a network in Packet Tracer. Really easy to do. A little more work to do, however. And you guys have any questions for me? Okay. All right, so those of you that are online, if you're interested in doing the next class, the second course, you also need to finish up the final exam and the skills assessment and the course feedback for this first course so that I can move you over into the next class as well. So I'm going to go ahead and hand out the lab for the students here. And the second lab as well, we can hold off on that. Here's 11.5.1. Okay, so it's the same one I just kind of showed you, the instructions here. You don't need to complete all of the addressing on here, but it's a good little exercise to kind of go and write them all down. You don't need to turn this into me tonight either. You can work on it. Let you want to feel comfortable that you know how to connect the terminal, connect the console cable, log onto the router. We've got plenty of routers out there, so you could each pick one to do. However, you only have the two hosts, right? So that makes it a little more difficult. So you can each configure one. You're working with a partner. So you can learn how to do the configuration, but then just pick one of the routers to be the router you're going to test, right? Between the two hosts. Right? So we've got got 24 routers out there, so there's enough. Everybody can have a router. But when you are ready to test, to see if you can, ping the gateway from this network from each of the hosts, you and your partner will pick one of the routers to serve as that role, and plug your cabling in accordingly. But to do this, right, APC to a router, you can each do that. You can pick one of the routers there, each, do the host name, do the banner, do the configurations. So there's no need for one of you to drive and the other person just to watch. You could both actually do each of those commands. And I think it's probably a good idea because ultimately you have to do it yourself on the skills assessment, right? Someone else can't do that for you. Okay, so we've got 2 hours. Head out to the lab. I've got the second lab available here too, so you need to make sure to pick one of those up before you leave tonight.